All right. We are now live with apparently the Sam Friedman, because I don't know how to spell, and Dylan Swartz here. How's it going, y'all?
Good. I am the one and only. Although,
Cool.
if you Google my name, you'll probably get through like 5 pages of Google search results before you get to anything that is close to relating to me.
It is a fairly common name, I feel like. So that's a tough one.
I like it. I
Yeah.
don't need to be searchable.
Yeah, that's fair. I feel like you don't have a huge online presence in general, or maybe it's a very covert online presence that you don't share with your coworkers. That could also be it. So,
I mean, the problem with a question like that is there's no, if it's covert, you wouldn't know.
right, exactly. Yeah. So you're just like, that's an interesting idea.
Yeah, maybe I do, maybe I don't.
Maybe so. Dylan Schwartz is also a pretty, I feel like, common name.
There's a Dylan Swartz who played like college football or something. So
Okay.
generally that's the first result. But I think my growing number of blog posts with my name attached to it is contributing to the SEO a little bit.
Nice.
I don't think it's that common.
Yeah, maybe not. I don't know that many folks named Dylan, I feel like. So
I did just Google myself for the first time in a very long time.
Flex.
And what I realized is that in the last couple of years, my name has gotten even worse to Google because now it's half the result is just Sam Bankman-Fried.
I didn't think about that. Good point. I guess a win for you. So honestly, except for I will say that I think at one point you came on the stream and afterwards one of my friends messaged me. I was like, for a second, I thought you were literally having Sam Bankman-Fried on the stream, which I was like, well, use some context clues, my man.
Yeah.
But
or also just like read.
Yeah, right. What? Yeah, exactly. Don't you know we're having the Sam Friedman on, not Sam Bankman-Fried? So. But before we jumped on, we were actually, I feel honestly, I feel embarrassed because y'all have so much greenery in your background today, and I brought nothing. I have a soldering. I do have a painting of Arches National Park, which is not very green at all, but it is outdoors. So
it is nature.
True. Yes.
It is erosion of nature.
I don't feel qualified for this topic. So
right.
Yeah. But Sam, I'm guessing that you're not growing the plants behind you.
No, I'm at a co-working space that I'm a member of, and this is their outdoor space, which is very nice. It's a very nice co-working space because it has outdoor space and greenery. But I'm in the middle of Brooklyn, so as I was showing these guys before, if you peek over the wall, it's just buildings and buildings and construction crews. So it's an oasis in a desert in a way.
In a way, for sure. Cool. Well,
have a manufactured oasis as well.
That's true. Yeah, we're actually all kind of in fake nature environments right now.
Directly to my left is a sky. To my right is a skyscraper. So
yeah. and yeah, weirdly, I'm in the most I live in a forest, so that in a not very city area. So yeah.
So you could say we're each escaping the environment that we're normally in.
Right. Exactly. Cool. So topic for the stream today is our Pipelines Hackathon recap. We talked about some of the projects last week because we were in the middle of the hackathon. We also talked about the JSON patch transformer, which we put out a blog post on this week. But yeah, I think we're just going to kind of recap some of the hacks that folks did. I think Dylan and I talked a little bit about ours last week. Sam has not yet. Also, Sam is our, what would the term be? Like master of ceremonies or something for our hackathons. So he's the
master of calendar invites.
Yeah, exactly. You took the initiative when no one else would. but also I did realize for if you want to demo your hack, which I think would be cool, which is not much of a hack, I need to do some stuff to make that happen. So I'll need a little lead time before we get into that portion of it. But overall, what were y'all's impressions of the hack day? How does it compare to previous hack days that we've had?
I thought it was a really good hack day. Each one is special in its own way, so I don't pick favorites. What is nice about this one is that it was more focused. We've had themes for some of our previous hack days, more like a fun way. This one, we just released Pipelines a few weeks ago, a month ago now. I don't know when we released it.
It is time.
And it's also kind of just like a foundational tool that enables a bunch of things. So we were excited for the new thing and also for the new possibilities. So we focused on that. So I thought it was nice that we were all kind of playing in the same realm, or most of us were playing in that same realm. Which, again, that's neither like a better or worse than any other, but it was different this time. So that was cool.
Very diplomatic of you. How about you, Dylan?
I thought it was great. We released Pipelines, which allows you to stream, transform, and route IoT data anywhere on May 28th, 2024. Sam. So yeah, it was cool because we just launched a new product. Everyone, of course, like we had a huge test party internally and all started using it internally before the launch, but post-launch got to use it in production, like everyone built some really cool things, including new features to Pipelines, which is pretty exciting. A lot of times hackathons in general don't result in features that go to production, but I like hackathons that do result in features that go to production, which is pretty cool.
Yeah, I definitely like that. And also, even if features do go to production, like I think the simulator might have started out as a hack day project. We've had a couple that have turned into production features, but usually there's like a bit of lag time. Whereas I feel like a number of the things that were introduced in this hackathon are like imminently or already in production, which I think is pretty neat. And also, I am getting your demo set up, Sam. So I need y'all to stall for me.
And when we say hackathon, that doesn't necessarily mean that it was hacky either. We have a lot of safety and testing and reliability that's allowed us to move quickly on Pipelines, I think.
Yeah, I will say mine's pretty hacky in its current state, but it won't be when I merge it and we deploy it.
Exactly.
How is your experience with Go going, Sam?
It went.
I do want to hear your takes on the language.
I like it. I was thinking about this. I mean, I think there's still a lot that I don't know about it, or it's a little like still unfamiliar. And I think there's probably also, so I mean, I am a firmware engineer, so I almost exclusively program in C. I mean, I've used I've learned other languages in the past, right? I haven't used Go before. Okay, sorry. So here's what I'm saying is that, like, there are maybe things that are like very impressive to me that are not specific to Go. They're just specific to things that aren't C, But I found it really easy to use. I guess the other sort of like higher level language that I use day to day is Python, which I know is like very, very different than Go, both in like a usability and like on like an implementation technical level. But as far as like being able to do things really easily, really quickly, right? I feel like they're both a lot easier for that than C. But whenever I use Python or see Python, it always feels quick and dirty and hacky. Like I'm sure, like I know there are like web apps out there, like big teams using Python, and I'm sure they write great Python. I've never seen it. Go, on the other hand, like it's still like really easy to like get things done, but it feels more semantic, like easier to read. It feels just much more like natural, I guess, through the things and more robust. Like it's quick, but it doesn't feel dirty. And but also, like part of that is, like I said, I'm usually like the Python I encounter is usually like scripts that are written, like very quickly, as a tool, versus like this Go code base I was in, is like brand new, hasn't like had a lot of time to, accumulate tech debt. It's like was architected really well, so there could be some like context there. But I think the main thing is it's just like there are a lot of things compared to Python for Go where it felt like it was really designed well for like larger code bases and integrating different modules and having everything work together. I don't know. Yeah, so it was good. It felt pretty similar. There were definitely little syntactic things I needed to learn, like casting works different. But and there's like colons in front of equal signs, for some weird reason. No, I'm kidding. I know why. But yeah, so there's little things like that. But I think once you get the hang of it, it starts flowing pretty easy.
Yeah, I mean, I feel like. Oh yeah, go ahead.
But I've been talking too long. Go ahead.
I was just gonna say, I feel like the fact that like you experience the number one feature of Go through building something in a hack day without like ever using the language for or ever using it like intensely before. And like the number one feature is it's like easy to learn and use, and so like, because I mean that, if you go to the origins of the language at Google, it's basically like we want to make it extremely easy for like new people to come in and contribute immediately. And so it is like, I feel like in that regard, it's similar to Python in terms of, like ease of use, but it's much more structured, which I think is nice because like, obviously we were going through a couple of the comments on your PR before this, and like, there's like error cases to check and that sort of thing. But in terms of like the typing of things, there's not really any question. In fact, I think like one of the things is like, getting things to the right type, especially with the nature of the hack that you did, is like very obvious, right? Like this like has to be an int, right? And so it's nice that that is apparent. It also makes it a lot easier to review, in my opinion. Whenever I'm reviewing like Python scripts that folks have written, I always find myself just being like, I just gotta clone this down and use it myself because I can't understand. Like it's a big cognitive burden to understand just by looking at it.
I like my types to be a mystery.
Are they
a true
all
product manager?
Yeah. Are they all just Dylan type 1, Dylan type 2?
I use a feature in JavaScript called type coercion, which magically changes my type to another type depending on what it thinks it should be.
Isn't that just okay? What you were talking about though, Dan, I think it's interesting because like in C there's a lot of conventions, and by a lot of I mean there's like different conventions, like not just like like there's different conventions for the same thing, depending on where you work or which code base you're in or just how you feel that day. But in Go they actually mean something. So like public fields, variables, members, whatever are capitalized and private ones are lowercase, right? Whereas like in C, you could totally do that for like readability, but you have to like remember to do it because compiler doesn't care. Like that doesn't mean anything.
Right.
But in Go, it's both like a readability thing, like you mentioned that way, but also like it actually changes it, right? Like just capitalizing or lowercasing something changes its visibility. Which I thought was interesting. Kind of goes to your thing of like there's only like one way of doing it. Like things that are just style in other languages are actual like features of the language in Go.
Yeah, absolutely. I feel like that when I'm working with firmware, which I think it's like a little bit easier if you're jumping into a code base that has like established conventions because you can just like observe the code around you to follow it. But I found a lot of times when I'm like starting a new project, which that's what I was doing for the hack day this time, where I'm kind of like I need to like go pick a project to basically like emulate the style of, right? So like a lot of times I'll use our firmware SDK or I'll use Zephyr or something like that, which I think our firmware SDK and Zephyr are fairly similar. But like, I like need to like decide up front what type of style I'm going to be writing in, and like there's like cognitive burden in that, which is kind of annoying. On the other hand, sometimes it's nice to have a little bit more choice there, whereas like I can't remember who I was talking to recently, but they were like, yeah, I don't know if I like formatted this Go correctly, and I was like, you did. Like, you don't have an option to do it. Like, did it compile? Then like, you format it correctly, and there's only one way to format Go, and it's enforced. So yeah, I think those capabilities or attributes make it well tuned for like what it does, but they can also be frustrating at times. So a lot of people have like they don't love like the polymorphism model of Go, but if you're coming from C, it's like, well, I guess there is like, void pointers are a polymorphism mechanism, but there's not like a built-in, there's not opinions about it in the language. So yeah. Anywho.
Yeah, I've always liked that about C. Or like, I mean, C is like very difficult. Well, it's difficult to learn how to like write good, safe C, or it takes a lot of time.
Right.
Because C gives you a bunch of tools, right? Like you can do whatever you want with it, which is both its like its power and its shortcoming. As someone who's like worked with C a long time, right, and like now I've learned all the different things that can like shoot myself in the foot. I really like having that power, and like the compiler and the CPU is going to do exactly what I tell it to do, because C gives me like the ability to tell it to do anything I want, which I really like and value, especially I think for firmware. It's really helpful because we need to interact with hardware and like low level features of the machine so often. Whereas like, you're not accessing, or you shouldn't be accessing like registers directly from your backend server code and things like that. And
Right.
so there's like maybe less need for that sort of less need for that sort of like direct access or that freedom. Go's not like a systems language, right? Like you couldn't compile it down to bare metal.
Right. There's a fork called TinyGo, which is like basically Go syntax with an LLVM backend, where they like attempt to do that. But no, it has like a fairly large runtime in there that's doing garbage collection and all that. Another thing that you made me think of when you're talking about C is like one of the biggest, I think, selling points of Go is the concurrency model. And so like in C, right, like once again, it's kind of like your concurrency model is like whatever you want it to be. And in Go, there's like very structured primitives for that. So obviously like there's like mutexes and semaphores and things of that nature, but there's also channels which make coordination. It has a very like opinionated view of how you coordinate between separate threads or separate Go routines, which is like extremely important if you're writing like a web server, which is like highly concurrent, and you're doing a lot of things at the same time. So I think that's something like you didn't run into, but it is both nice and also it's not like foolproof, right? It's still hard, and like a lot of folks, especially who are newer to Go, when they kind of like get accustomed to like the general syntax, and then they like, I feel like concurrency is like the next level, and then they're like, oh, this actually complicates things quite a bit. And it's pretty easy to like, leak Go routines or do something like that. So it's not like like memory safety does not necessarily mean like safety from everything, which I think is something that folks get confused about with languages like Go, or like a language like Rust or something, where like just because you have memory safety doesn't mean you're excluded from all programming bugs ever. So
yeah. It's impossible to write wrong code in
right,
in Rust.
exactly.
In Rust, at least. I mean,
Right.
Rust is the perfect language.
Right, exactly. I apologize to all the Rust folks who I've just offended. Yeah. Well, anyway, so while we've been talking, I think that I got things in order for for your transformer that you wrote for Hack Day if you're interested in demoing it. Although I did not warn you beforehand, so I don't know if you're prepped for that or not.
I just while we were talking, I also took the opportunity to get it up and running. So I think it's up and running. It looks like it's working. So I think we can do
Cool.
this. Let me make sure there's no yeah.
You close your Slack windows.
Oh yeah, that's a good idea. Okay, it's done. Cool. Okay, so is this showing up? Yeah.
Yeah, let me pull it on the screen here. There we go.
Okay, so my demo is a struct to JSON transformer. By struct, I mean like a binary data in the same format that you would get from like a pack-C struct. And what you do is, so this is our pipeline configuration. So this is the transformer struct to JSON, and what you do is you just list out the name and the type of each field. So for this one, this is a temperature, latitude, longitude, and they're all floats. That matches actually lists like the default data that you get from our simulator. And you can imagine this is for like if you're tracking cold chain data. So you have like frozen food in a truck somewhere and you want to know where it is and make sure that its temperature is still good. In this case, well, hopefully that's Fahrenheit, because if not, it's definitely not cold. So what that looks like in practice, so I have over here, I wrote this little quick Linux program to send up that data. So right here, we have this pack struct with our 3 floats in it, temperature, latitude, longitude. I'm just populating it with hard-coded data that matches our simulator values. And then I am sending it to the stream service, which is basically pipelines with the at the cold chain path. And so let's go out of here. Let's actually, I'm going to turn off this one for right now. Okay, so that's on. And then if I'm going to refresh this so you can see it coming through. And in a minute there. There we go. So we're getting our latitude, longitude, temperature data. So this looks the same as if you had just sent a JSON payload or a CBOR payload, but we're sending it as just binary data. Why you would want to do that is it's much, much more compact. So that this JSON payload, if you like take out all the white space, I think I calculated it to be 44 bytes. If you sent the equivalent CBOR, it's 30 bytes. In this binary struct format, it's 12 bytes. So it's 3.5 times smaller than the JSON payload. It's like 2.5 times smaller. Is that right? Yeah, than a CBOR payload. So it's much, much smaller. Of course, it's not going to be as flexible. Like you need to know that it is structured data. So you need to know the format of it ahead of time. And it'll be a little bit harder to like update that over time. But if you do have data that you know is going to change very much, it's in this structure, you can save a lot of bytes doing it this way. You can also, it's something we've discussed is that it's also useful for like retrofit opportunities. For like a lot of IoT devices, this is what they do. They send binary data directly, especially if they're over like a constrained link, like cellular or Bluetooth. And so this would allow you to like take those devices that are already sending that data and adapt that firmware a lot easier to send it through Goliath. Obviously, though, like web databases don't like binary data like that. They like, this sort of feed data like JSON or whatever. So this then lets you translate it into what you'll need for your web app, which is the whole value prop of Goliath, being that middle between your device and the cloud. This can do a couple other things too. So I have this other one here, which is sending strings. It's going to send 2 strings. One is a fixed length string. The next one is a dynamic length. So we're using sees variable length arrays. So right now I'm setting the first string to hello, which is 5 characters, and the second one to world, which is also 5 characters. But we're setting that string length dynamically. And so if we go back to the pipelines, that's what this one looks like. So we've got 3 fields here. We've got our fixed length string. We've got a 8-bit unsigned integer for the length. And then we've got our variable length string, which is using that string to length field as the length of that string. So if we turn this one on and save it and go back to the device, we can see it's sending hello world with the string length. And then because it's all dynamic, we can change this. So we can say this to Golioth, save it. And over here, I can rebuild it, rerun it. And now we're seeing hello Golioth with a string length of 8. And then the last little thing that I did isn't really part of my hack day, but I think shows what you can gain by stringing different transformers together. So once we have pulled out that string length, we actually don't really care about it anymore. So we can use a JSON path transformer to remove that string length from the payload. And if we go back to the device, now we just see hello Golioth with no string length, even though it is dynamically using that string length to know how many bytes to convert into that string. Yeah, so that was my hack. I was really happy with how it turned out. Like I said, or like we were discussing earlier, Go is like pretty easy to pick up. So with some help from Dan and a few pointers, it went really well. The other thing, like I think I mentioned briefly earlier, is that the code base is brand new and it's set up really well. These transformers are all their own like self-contained little module. It's like a very simple function, data in, data out. So it's nice to be just in that architecture, like very isolated in my own little world. It was like really straightforward to add a new transformer, which makes me excited to think about what else I can do now that I am officially a backend engineer.
Right. Yeah, I remember when you were starting working on this on Friday, you were asking, like, how can I, stand up Turbine to what Turbine is our like pipelines internal name for the infrastructure that runs pipelines. And I was like, you could do that, but like maybe just run some unit tests. And because it is just like all of the like literally the kind of like user experience you have for transformers and destinations is kind of how the infrastructure is structured as well. So it's like it's just data in, data out, which is also nice for if in the future we allow for like custom code to be run or like custom transformations or destinations, like basically the same interface we use, we can just pass along to an arbitrary implementer. In fact, I think we did on the stream maybe a while back, maybe not actually, but we have a like a WebAssembly one where we can create like dynamic modules too, where it basically just like instantiates the module with exported and imported functions to be able to like pass in and out of the WebAssembly memory space, just like the data and then the return of whatever the transform thing is. So yeah, I think we'll be able to continue to build on that hopefully. But yeah, we definitely want to get this one to production because I think this is certainly useful for folks. You also mentioned like the JSON support for getting things into other cloud systems, but I think the patch transformer really like shows it's like once you get things to a common interface, like the building blocks of pipelines is really on display. So like I like it because every time we add a new transformer or destination, it's like as you said earlier, like greater than the sum of its parts, right? Because you can start to kind of like chain things together and do sometimes even unexpected things. So yeah, it's a lot of fun.
Yeah. I will say, I mean, it all worked out great just using unit tests to test this and build this. Maybe this is also just like coming from C and doing firmware. Like I'm always like my reaction is like, sure, I'll unit test it. It's not going to work though when I put it together.
Yeah.
But it did actually. It worked great the first time. The thing I was a little bit worried about was like translating from the description of the parameters that list of fields in the struct in YAML to the Go slice that I was taking in as the argument in the transformer. But it did end up working. There's a lot of great infrastructure for that too, which also feels like magic to me. I was asking Dan about it earlier. because I was like manually parsing it, and he's like, "Oh, you don't have to do that. Actually, you can just set it, and it all like get translated from this YAML, format into like a Ghost ref." Which was amazing to me. I told him I felt like a caveman asking why I didn't have to light the light bulb on fire in order to make it glow, because that's what it felt like coming from C all the time.
Yeah, the serialization and deserialization kind of primitives or standard library support in Go is really nice, and it also allows you to like extend it to do other things, and it has like built-in things that language like struct tags or struct field tags to be able to like say, this is how I want you to translate it. And then behind the scenes, like I think we're using map structure, which some folks might be familiar with that library, but it allows you to basically take like a arbitrary map, a map of like empty interfaces essentially, and then like convert it to a typed representation using reflection. So yeah, lots of fun goodies. It is fun to compare that to like parsing CBOR or something like that in the firmware SDK, where it's a little bit more involved for sure.
Yeah, definitely.
Yeah. Cool. Well, thanks for demoing, and thanks for putting that hack together. Hopefully, we're thinking maybe next week we might have this available for folks. So I just put Sam on the clock there. So.
No, I think so. I was working on adjusting some of the comments a little bit today. I do have one or two other things that are a little higher priority, but they also have deadlines early in the week. So I think this would be fine.
Nice. Cool. Dylan, you also talked about what you were working on during our stream last week. How did it kind of like come along after that, leading up to demos on Tuesday?
Yeah, I am a noob. I'm not a noob. I'm a rusty programmer, I would say, because
was that a Rust reference?
Yeah, you program in Rust.
I don't program in Rust. I identify as Rust.
So do all other Rust developers
for 7 years, and then have been doing product management for like 7 now. So I'm a little slower in my hacks. Plus, we had a couple meetings that day, but effectively, what I was able to do is port a hack that I did previously in I'm trying to untangle some cables here. I have this NRF 9160 attached to an Arducam 5 megapixel camera. And previously on a hack, Mike, who's many of you may have seen on other streams, Mike and I made a little bird feeder camera that was meant to detect birds, take pictures of them, and then send it through Golioth. And previously that used output streams, and I had written a little web service to receive those images and then do some processing, and converted that into a pipelines world. And one thing that was really cool, I also had the intention of using it to detect a disease on plants using AI, and I did not get to that piece. But one thing that was really cool is switching from output streams to pipelines. I was able to delete a lot of code in my own backend service. Previously, I had to do like logic to detect like which messages were coming in, because we were chunking images and then like sending a command to say the final chunk of the image was received, and then doing an post-processing to reassemble that image and then store it in a blob store. With pipelines, I could remove that logic from my backend service to determine what LightDB stream messages were coming in, basically, and then instead create individual pipelines for different routes in my backend API, which really simplified the logic. So that was cool to just kind of use and experience the features that we've been talking about as a user. One of these days, I'll get some more time to utilize one of our new features, which is the ability to send up, kind of like Sam was just talking, binary data. Previously, that hack, I was packing the chunks of images into JSON because that was a constraint of our platform in a pre-pipelines world. Now you can send basically arbitrary data. So refactoring the firmware code will take me a little longer because I'm not good at C. But refactoring that to send up binary data is the next goal. And then we get to detect plant diseases.
And
You're not good at C
I
yet.
guess, yeah, I guess when you do it, it'll still be in like chunks of binary data, right? But hopefully, sometime soon, you can just send us the whole image, and then we will do something with it, which is undecided yet. But
I'm gonna do just in time refactoring every time we add a new feature that makes it easier. But yeah, we accept binary data now, but it's limited by like the size that you can send in a co-op message. But if you're reading our release notes closely on the SDK, you may see a line item that says blockwise uploads, which soon will become better for the user of that feature.
And
yes,
Dylan
we
has
have
just
support
teed
for
me
it.
up as well.
Oh, okay, great. You should go.
Well, wait, what were you gonna say? I still have I have a tiny bit of setup, so continue.
Oh, okay. Well, I was gonna say, so we have been talking about blockwise uploads in our release notes. We've done blockwise downloads for a long time. That's how we do OTAs. But our blockwise upload API exists. It's just not exposed to users. So there's this great new functionality that we've been putting out in our open source code that you may not directly be able to access yet, but you can imagine we're not doing it for nothing.
Well, I might be letting the cat out of the bag a little bit with my demo, but oh no, actually I realized that I think that my Chrome is gonna crash if I share my terminal. That's a bummer. I can still share the screen though. I
Take
don't remember.
screenshots of your terminal and then open it in Chrome.
I have done that I did that on a meeting when I was pairing with someone this week because I couldn't share my screen. But well, okay. Well, we will just imagine that we can see it because I'm pretty sure if I try to share, it's going to kick me out, and that might actually end the stream as well. But I might be able to paste it into something though. Hold on. Talk amongst yourselves.
For context, Dan likes to be on the bleeding edge with his Linux distribution, and he's having problems screen sharing now. Every time he tries to screen share his screen, his browser crashes.
Yes.
Feels like 2009 when you couldn't even get a graphics card into your Linux distro.
Exactly.
Back in the day, used to like to fiddle with Compiz Fusion in my Linux distribution, which let you create virtual desktops that like rotated like a cube when you switched the virtual desktops, and editing all of the config files for that always just broke my computer completely. But
I forgot about
I
stuff
did it
like
anyway.
that. I feel like we used to have a lot more like 3D transitions and stuff on our laptops. I feel like anytime some new technology comes out, they're like, look at this cool thing we can do that's not useful at all. And then a few years later, we just stop doing it and forget about it.
I spent so much time of my life just like editing the GNOME experience to make it like look cool.
For yourself,
and
because you
usually
weren't like
made it
showing
worse.
your
Correct.
laptop.
It was
to
just
anyone.
on my
your desktop.
personal time. I was also a teenager at the time, so I literally had no one to show it to but myself.
All right. I I have copied it into a gist or a gist or whichever one you prefer. This weekend I'm going to fix this issue with my screen sharing, but alas, not today. Okay. So also I want to caveat with this is very gross. I did not clean it up before coming on here. But anyway, this is the firmware for my Hack Day project. And it's pretty heavily inspired by some of the expressive examples from both their board support package repo, the ESP-BSP, which I always have fun saying, and a little bit from the ADF framework, if I guess that's repetitive, the AD framework, the ADF, ESP ADF, which is kind of like the audio development framework that's like a complement to ESP IDF. So as a reminder, Chris and Jonathan and I were kind of building on this M5 stack Core S3. So it has a ESP32 S3 module in here. And so kind of the part that I focused on was using the microphones and the ADC in here to record an audio snippet and then upload that to Golioth using some of the Blockwise stuff that Sam and Dylan were just talking about there. Sam also gave me an assist on an example with the you had an image upload example that I kind of took inspiration from, and to be able to use some of those Blockwise APIs. And so yeah, I was able to record some audio, upload it to Golioth, and then my hack was, let's see if I can actually find it. I think it's this one, yeah. Was to introduce this transcribe transformer here. So we're taking binary data again, and then we're transcribing it. And this uses OpenAI's Whisper model, the hosted version, so that their speech to text service. And then it gives you back JSON. And so we can just insert that into LightDB Stream. So yeah, I'll briefly show how the firmware is working. So basically I'm taking we'll just start with the audio. Maybe I should make this a little bigger too. Okay, so we start up, and this is just initializing the ES7210, which is the ADC on this board. And once again, this is from like the board support package, so they kind of take care of it for you. But essentially, you have to issue some I2C commands to the ADC to set it up to record at like the sample rate that you want and that sort of thing. So in here, we're using sample rate, 1 channel, 16 bits per sample. And so I'm recording about 5 seconds of audio here, which you can see how we're coming to that because we're using 16,000 hertz for our sample rate, and we're using 16-bit audio. So anyway, that kind of evens out to that. The thing that I had the most trouble with is I was initially trying to use the SPIFs file system, which is like a SPI file system that you can use with, I guess, any embedded device, but there's nice support with ESP-IDF. And let me see if I can find where I'm actually recording here. Yeah, so when I actually read from the device, I was initially doing this in a loop, kind of based on the example from Expressive, but the latency in writing it to Flash was much too long. And so actually, I think it was maybe yesterday that I uploaded that sample audio to Slack, and it was like, every it was 5 seconds of audio, but it was like every, however many milliseconds of time, was like a snippet of sound because I was missing time trying to get that over I2S. So anyway, I ended up just using, this has external RAM in here. It has, I think, 8 megabytes of external RAM, the PS RAM or pseudostatic RAM. And you can just, I don't have the config here, but you can map that into the memory space. And then basically just allocate on the heap to it. So here you can see I'm using the SPI RAM capability when allocating this memory. So basically I just allocate the entire audio buffer in memory and then read directly into it. And then this is using the Blockwise upload here to send it to stream/AI. And this read block buff is kind of what you inspired, Sam, where I'm just passing in that buffer and then taking the offset and just kind of doing each block and uploading. So yeah,
cool.
I can give it a quick demo here. Like I said, you won't be able to see the logs coming off of this in my terminal here, but we'll see. Does anyone have a request for the audio that we want to transcribe?
Yeah, sing Twinkle Twinkle Little Star.
Okay. Sounds good. Okay, so it should be this device. Also, I will caveat that while I was changing Sam's stuff, I also was changing a fair amount of other things. And this is our development environment for folks who didn't catch that. So this could very well not work here. But I have video evidence that it did at one point. All right. Twinkle, twinkle, little star, how I wonder what you are. Isn't it where you are? Darn it. Let's see.
I thought it was
appears
what?
to be. It's what? Okay, cool.
I'll
Also,
look
I
it up.
realize I'm sharing the wrong tab, but okay. So this should, it does take it a bit to upload the audio because it's a lot of data. But we should see a message come through here, or it should be upset at some point. It's still uploading. I can see.
I asked you to sing it.
That was me singing. I regret to inform you. Let's see. Hey.
Nice.
And it worked.
Cool. And it worked.
Twinkle, twinkle, little star, how I wonder what you are.
It is
I
what?
looked it up. That's correct.
All right. Doesn't this individual know what a star is? It seems like it'd be where. I guess they also know where it is because they're looking
up above the world so high.
Right.
Like a diamond in the sky.
Right. If I'd kept if my context window was larger, I would have known that it was up above.
Were you never like a curious child? Like, okay, it's a bright light in the sky, but like, what is it? You know,
that feels like
you don't look at a star. You don't look at a star and go, oh wow, that's definitely a giant burning ball of gas, like a bajillion miles away from me.
You know, Sam, I feel like you've spent enough time with me at this point that you would believe that it might be plausible that I would be like, yeah, that's just a burning ball up there. I'm not fascinated by this. I'm not impressed by this. But anyway, that was the demo. There's a little bit more stuff that's not encapsulated in there that I've done since then, but I'm glad that it worked for us there.
Yeah, that's cool. So we are gonna release that, right?
The transcribe transformer?
Yes.
We'll see on that one. I'm not actually sure. I mean, I'd be interested to hear how folks, anyone who's listening, if that would be useful. I'm not sure like how many folks would find a lot of value in it. It's also interesting from like a perspective of I mean, we're just calling OpenAI with your API key, so that's fine. But like pricing model and that sort of thing are all interesting in that realm because that would be the first transformer that actually reaches outside and does things. Obviously, our destinations do that, but this would be the first transformer where we're calling an API, which is a bit of a different model just in terms of like how we're handling, you know, the duration of a pipeline and that sort of thing. So. But maybe.
Yeah, that was gonna be my next question too. If how do you envision anyone using it? But I also feel
don't.
like I don't know.
I mean,
feel like
maybe.
What's great about these transformers is if we can build them. I mean, well, it's like mostly built, right? I mean, I'm sure there's still like work to do, but you know, a part of it I think is just like giving people building blocks and like seeing what they come up with, right?
Yeah. Yeah, I know. So the only thing I could think of for the transcription one is like surveillance related. And then I was like, I don't know. I don't know if I want to release this.
There are a number of use cases around uploading audio from microcontroller based devices that aren't necessarily transcribed into human words.
Mm-hmm.
For example, I've seen a couple of companies and there's like nonprofits in the space that will put sensors like in the forest to detect like poaching. Like if you hear gunshots or like logging, and like they can detect chainsaws and then dispatch the government entity that goes and stops those people. And then things like baby monitors and that sort of thing detect like crying and notify the parents and that sort of thing.
Yeah. I wonder if in like those cases, I imagine, well, I think it could vary quite a bit depending. But you're probably not, or at least I wouldn't recommend like uploading the entire audio, because you can likely just do detection of like, in those cases, it all sounds like large increases in volume, right? Or it wouldn't be volume, but like a large change that you can probably detect without actually having to send the audio up for like processing.
Yeah.
So yeah.
Or
I think
or some kind of edge model. Like I know another
Yeah.
application is like industrial monitoring. Like
Mhm.
gears sound different when they're worn down and are about to break. So you can like put in your heavy machinery and listen to how the machine sound changes for predictive maintenance.
Yeah.
Processing that on the device, maybe you detect an anomaly, and then you could send up that snippet of sound for like validation or something.
Or training.
You trigger on the gears sounding really bad, and then you send up the audio to transcribe the operator going, "Oh shit, oh shit."
I think you've unlocked it. We're making a pivot, folks. It's operator expletive detection is our new we're releasing a new model. Nice.
There was something else I was gonna say, but I forgot what it was. Something a little earlier.
Oh, cool. What are y'all up to this weekend? Or if you had more things to say about, what we're doing, that's also fine, of course.
This weekend, I'm going to do a concert tomorrow night. I'm pretty excited about. It's the Pixies, which I'm excited, even though they won't have Kim Deal. There's also going to be Modest Mouse, which I'm like pretty, like very not excited about. I mean, it's cool. I can tell people I went to a Modest Mouse concert. I guess I can float on, but like definitely going for the Pixies. And then the opener is going to be Cat Power, which is also cool, but I feel like doesn't really mesh with the Pixies or Modest Mouse, other than they were like active in a similar time frame. But anyway, that's what I'm doing tomorrow night. And then I'm seeing a play on Sunday. I don't know what it is. It's in the fall. I signed up for like a season tickets to the theater because there was one play I wanted to see and it just made sense to like see them all. So it'll be a little bit of a surprise.
Well, that's cool. You're once again proving that like you are more cultured / you live in New York City. And well, I guess Dylan lives in Chicago.
Is cooler than everyone else.
I think cool is all relative.
Yeah.
I said the Sam is
the Sam.
It's always got cooler plans than us anyway. I'll probably be doing work this weekend. Not that it's not work that I'm not excited about. I've mentioned a couple times my wife's opening a store, so my weekend is like helping with some of that. Might get to do some scripting or something to try to format a bunch of spreadsheets of inventory and then load them into Square. That's probably a project. And then there is a thing that could be entertaining that we may or may not do. There's public transit in Chicago, both buses and trains. The trains are called the L train. One of the lines, the brown line on the L train, has some sort of special event happening that you have to buy a ticket that's different than a regular ticket to get on the train. And it's a rave on the train. So there's going to be like scary. DJs on the train. I have no idea what that looks like or what that sounds like, because I can't imagine the audio quality on a train is that great, but it could be interesting.
I don't know why you said, oh wow, Sam, but it sounded sort of like oh, you have public transportation, that's so crazy. But for someone like me, I'm like, that is crazy. That is extremely crazy. I can't even imagine.
Yeah,
I know
have
Dan's a big
feeling
fan
about
of public transportation. That's definitely added to my
Yeah.
grandeur there with the description.
I was in DC last weekend, which is like not very far from here, it turns out. But it takes quite a long time to get there because the traffic going into DC is absolutely outrageous. But the public transportation there, I was just like wanting to ride the train around all the time because it's like it is the nicest public transportation I've seen in the US, I think.
DC.
Yeah.
Yeah, you must have been on those new trains. They did replace. I grew up around DC, and it is a lot nicer than it used to be. I will say that like, especially if you're like visiting for like tourist things or you're commuting into the city, the trains are
Mhm.
really nice because they're sort of designed to be, which actually a lot of transportation systems in the U.S. are designed this way. Um, they're designed to be like local commuter trains, so they're like halfway in between like big commuter trains like the Long Island Railroad and then like local subways like the L or like the New York City subway. They're kind of designed to like do both, and so they're really only great for getting from like local suburbs into like work areas.
Mhm.
But a few years ago, maybe like 10-ish years ago, the DC Metro was like super behind on its maintenance, and trains were just catching on fire all the time. And there was a website, isthemetroonfire.com. It's like one of those joke websites that would just say yes or no. Um, but anyway, so after all that, they like shut down big parts of it for like months at a time, and they rebuilt the tracks and everything. And then they got these new trains. So it used to be like these like 70s era trains with like worn out carpeting and these pastel colored like molded plastic seats. Now they're like brightly lit and like clean floors and like these nice slim seats. It is nice now. I'll say yeah, it's nice now. But
It's like,
you
yeah,
don't you
it's
don't
so
know.
clean.
Yeah, it's pretty clean. Um, I don't know. I guess I have like some history with the DC Metro.
Yeah. So I'm sorry for bringing that up for you, Sam. Maybe we could get out to Norway to see Trond, and all of our public transportation here would look terrible. Actually, I haven't been to Norway. I've only been to Sweden and Denmark, but I assume that Norway also has great trains. I don't know if either of y'all have been.
I've not.
Mm.
Yeah. I am a big fan of the New York City subway. It's not as nice as, like Asia or some places in Europe for sure. But it goes everywhere and it's
Yeah.
faster than driving. And so I think that's like the big compared to places like DC or San Francisco has a system that's like similar to DC. Like if you want to like get around the city, like those systems aren't so great for it. They're more about like getting you in and out. Whereas I really like the New York City subway can get you around the city.
Yeah, I think that's definitely fair. I mean, like in San Francisco, I feel like the only purpose is getting to the airport and back. Like,
Yeah. Yeah. And there's like politics behind a lot of it too. Like a lot of neighborhoods in DC and San Francisco, where like we don't want public transportation here. We don't want them to like bring the riffraff.
Nice.
Whereas like actually New York had that same sort of like politics too, but it wasn't we don't want public transportation. It's we just want our public transportation to be separate from the public transportation. Of that like the riffraff use. And this was a certain period of time, so riffraff is a euphemism. You can imagine what the white people in New York were talking about 100 years ago. But it's why the A train, people might know if you watch The Boys, the A train is the fastest train in New York City. And it's because it does not stop on the Upper West Side of Manhattan. It goes straight from Midtown to Harlem. And the reason it does that is because all the people on the Upper West Side who lived there, the white people, did not want the residents of Harlem riding a train that stopped in their neighborhood.
Yeah.
So there is another train that goes along the same tracks. It just makes the local stops, and that's what white people back then rode.
Yeah.
Yeah, I think it is fascinating to me how much of like our built infrastructure reflects the politics and the like society of the era in which it was built.
Yeah. Yeah, that's for sure. I mean, St. Louis, that was very much on display. So perhaps more than anywhere I've ever been in my life. But yeah, it is crazy. Well, I'm not doing anything this weekend. Thanks for asking, though. So actually, I will say, I feel like every time I say anything that I'm doing, I'm like, I don't know, there's a basketball game on, and my whole weekend revolves around watching that. But the NBA Finals are going on, and Boston is up 3-0, so they need one more win to finish it. And one of my very close friends just moved here, and he's from Boston, so he's been watching them at our house. So we're gonna have a good time doing that tonight. But besides that, I'm not gonna do anything else, which I'm very excited for because that's the first time in a few weekends. But yeah.
What were you doing in DC last weekend?
One of our friends who lived here and Katie went to school with, she graduated last year. And then she had lived in DC before she came to Duke. And then she went back she works at the National Gallery of Art, which is like the coolest building I've ever been in. And so yeah, so she works there, and it was her birthday, so we drove up to celebrate her birthday, and then came back because we're amazing friends. So it was very cool. She lives in like Logan Circle, or at Logan Circle, and there's like a rooftop place on her apartment, and so like we had the party up there, which was pretty neat. For me, it felt like this is the big city, so it was a good time.
Yeah, DC is cool. Rooftops have nice views in DC because there's like a height limit. Nothing can be taller, I think, than the Capitol Dome. So it's like a very low city.
Yeah. I will say, so it was they're having the Pride Parade in DC this weekend, and Logan Circle is like, it's kind of like actually I don't know what the full blocked off area is, but there is essentially kind of like a rectangle, and Logan Circle was in the center of it. And so like it took once we got there, we had to like park far away, and then I actually dropped off the other people who we went up with some other folks as well, and like dropped them off, and then I drove like somewhere else and parked, and then walked for quite a long time before I got to there. So that did complicate things, but I will say the vibes in the city were amazing. Like it was one of the bigger like parades I've ever been at, like in person. So it was a lot of fun. It's a cool weekend.
So you do cool things too.
Yeah, rarely, but every once in a while I do cool things by association, But yeah, it was a good time. Well, cool. I think that we've met our quota. I don't know about y'all. I'll stay on if you want to keep talking, but but we might have some work to do. So maybe we can wrap it up here.
I also realized that whenever these people are standing off of the wall, a couple of buildings over, it's like falling on me. They're not wearing masks.
Good for your lungs.
So yeah. They're not wearing masks, so either it's totally safe, or I'll just see them in the hospital next week.
Yeah, right. Hopefully not.
Yeah.
Well, cool. Well, I hope you all have a great weekend. Thanks to everyone who tuned in this week, and stay tuned for some more fun product releases next week.
Cool. Bye, y'all.
See y'all.